All right, we're going to talk a little about a new scalar model of physics. And here's the abstract, and I'll just read this for you because you probably can't read it from where you are. But this is really the heart of the matter. The quest of modern physics has been to develop a model which correctly describes the role and dynamics of the interactions by which nature works. In order for the model which describes these interactions to be robust, it must not only accommodate phenomena which are known to occur, but must also accommodate all rigorously documented phenomena, predict phenomena which are as yet undiscovered, and allow for the inclusion of all rigorously observed, impeccably documented, carefully reported data derived from all valid sources. To be adequate, any universally applicable physical model must also accommodate the contemporaneous interaction between Descartes' physical stuff and what he referred to as spirit stuff with equal cogency and grace. The physical model, as we've inherited it, this legacy from Descartes, really cuts the universe in half. It arbitrarily separates anything that cannot be seen or measured directly as spirit stuff, which remained the sole and undisputed territory of the Catholic Church.
At their request.
Yes.
At their request, as a deal they made,
Yeah.
because they were still suffering from the repercussions of Copernicus and Galileo at the time. And I mean, they were aware that the doctrinal discord between what they said was going on and what the science really demonstrated was going on was so indisputably clear that they couldn't argue about it. So they just decided to pick their own battlefield and claim all the unseen spirit stuff as the sole province of the church. And Descartes didn't disagree with that because he didn't think there was anything to it anyway. So he gave that up. Descartes and his gentleman friends, wealthy landed royal gentry, who are the only ones who could afford to do this naturalist observation stuff in the first place. Everybody else was working for a living, trying to survive. Descartes and his rich buddies went out and did science. And that deal remains very much intact today. In fact, our legacy is so strongly embedded in the way our culture operates that anybody who pretends to be a serious credentialed scientist, who embarks on a journey intended to rigorously inspect, report, and validate on the unseen spirit stuff, the stuff of mind and consciousness and scalar interactions, non-local field effects, holographic coupling, all of those kinds of things, outside the mainstream of science, runs the risk of being stripped of their credentials and ostracized from the scientific community. There are some fundamental issues with the standard model, notwithstanding the not physical stuff, that are either flawed by concept or seriously misinformed, not fully eliminated. One of these is the notion of the Big Bang. The Big Bang is fundamentally a statement based on the cultural requirement that all things have a beginning and an end. Okay? This is cultural. And so science now says that there was a beginning point, and they call this beginning point the Big Bang. And the Big Bang theory, everybody knows all about this singularity 15.3 billion years ago, that, over a period of microseconds, everything in the universe that was going to be created was instantly created. And since then, there's nothing new in the universe, just exchanges of things from one form to the next. That's it. But there are some things about the Big Bang model that are fundamentally indefensible. You just can't explain them away without going to such extreme lengths by creating all kinds of special conditions and variables, even in the most rigorous mathematics, that you can't defend it. And one of the things we do in the Y-bias model is address the Big Bang. So what we do in this thing is say, look, here are some issues that can't be accommodated in the science of it. Non-local effects at a distance. We talked a little about that last night, about splitting a positron-electron pair and shooting it out through fiber optic and being able to change this one and have the other automatically, instantaneously alter to accommodate a zero-sum reintegration with zero time-lapsed at 60 kilometers. 10 to the 9 times faster than the speed of light, which is essentially an infinite difference, right? Can't accommodate that. There is the high-density charge cluster phenomenon developed by Ken Shoulders. It's not accommodated by the standard model, but we use it in apparatus and it works. And we have pictures of them, so we know they're not a figment of somebody's imagination. And there's a long list of those. We don't need to go through all of them. Okay. Many of the errors in the standard model have been the subject of remediation attempts. A lot of really smart people have worked very hard to fix the errors. One of those Brian's personally familiar with, and that is that back in the mid to late 90s, a team of 18 mathematicians and scientists got together with Tom Bearden, Myron Evans, Larry Crowell, Donnie Reed, a bunch of very, very competent, smart people, and they rewrote Maxwell's electrodynamic equations. Well, why the hell did they do that? Well, electrodynamic equations, 1854, constitute the basis of everything we do with electrodynamics. But in the original equations, which were called quaternions, there were 4 simultaneous unknown variables, one of which was time. And it would take, 100 mathematicians 10 years to solve one of those equations working with pencils and paper. I mean, it's just very serious stuff. So in 1905, Cedric Lorenz, a Hungarian mathematician, came along and imposed what is called the Lorenz
transformation.
Yes. What's the word I'm looking for? A transform.
Yeah.
Lorenz transform. What the Lorenz transform does is it takes mathematics and it eliminates the delta t. That's gone from the equation. Okay? Now you have just 3 dimensions. Okay? So now you have only 3 variables to work with, and then it begins to eliminate any consideration of the underlying stressors, tensors, vectors. The analogy I like to use is that it did to mathematics what is equivalent to taking a big, long, powerful river, covering it with ice, and then claiming that what you see is all there is. That the river is not under there anymore. Because they did that, it simplified electrodynamics and it gave them a way to design motors and generators and rectifiers and all of the electrical equipment. But the reason the electrical equipment doesn't work with anywhere near the right kind of efficiency is because they left the other stuff out. So today, in any PhD program in electrodynamics in any university in the world, not one of the equations that Maxwell derived is in the textbook. Not one. And none of the text formulas were part of his original formulations. They've all been altered. All. So what the Union of Distinguished Scientists did was rewrite all these pieces, 60 different papers. They put it into one volume, and it's called Reformulation of Maxwell's Electrodynamic Equations. And I have one of those. And if you want a copy, I'll make a copy and send it to you. I mean, they're right on the money. They corrected 23 fundamental errors in electrodynamic formulation. In addition to that, Ruggero Santilli rewrote the laws of hadronic mechanics, what goes on with neutrons and protons and electrons and neutrinos and all 26 of the hadronic particles. He wrote a brand new model for that, and we use it. It works. It's wonderful. A guy named Mahmoud Melehi reformulated the laws of thermodynamics, and his reformulation of the laws of thermodynamics fundamentally alters how you talk about the second law of thermodynamics. the conservation of mass and energy. Fundamentally rewrites that rule. Because many of the technologies we're talking about are related to things that go on in electrodynamic equations that violate the way the second law of thermodynamics is written. It's wrong. Doesn't mean there isn't a conservation, but the way it's characterized is wrong. Okay? And then, in 2008, you wouldn't believe it, the United States Patent and Trademark Office issued a patent to Ted McGrath, a physics professor at the University of Miami. It's called Physical Quantum Model for the Atom. They issued a patent on the way he describes the quantum relationships and dynamics that operate in the atom. And he's right on the money. What you're going to see here is exactly what's in his patent. It was an unanticipated third-party validation of our model 3 years after we published. So we know we're right on the right track. All right. There's some fundamental things in physics that nobody's really been able to explain. And we have to give credit to Tom Bearden for solving this specific problem. One of the issues that you deal with in the standard physical model is that definitions of attributes and properties are circular. For example, if you go to the physics dictionary and you look up mass, you will discover that according to physicists, mass is defined as an intrinsic property of matter. Nobody says, where did the mass come from? It is presumed that in all matter, all mass is simply present by definition. So what it means is that science doesn't describe what is mass in terms of what the hell is it? Where did it come from? How does it come into being? How does it interact? What is it all about? What are the dynamics of mass? Science doesn't give you an answer because the standard model does not provide it. We do. A second kind of question you ask is, what is magnetism? Magnetism is a property of certain classes of materials in the periodic table. There are only 6 of them that are naturally occurring magnetic. We know a lot of things about magnetic fields, but we do not have a definition. What is magnetism? How is it derived? Where does it come from? Exactly what is it and how does it work? Standard model doesn't tell you. Endless books of formulations about magnetic fields, but not a definition of what it is. What Tom Bearden solved is what's called the source charge problem. And the problem simply stated is that when you have a physical interaction in an atom, for example, that emits electrons, like thorium, where do those electrons come from? Ultimately, there has to be a source. There has to be a source. The Big Bang model says that, they were all created in the instant of the Big Bang and they're everywhere, ubiquitously available in free space, and there's an unlimited supply of electrons. Well, we know that's not true because we know that electrons can be split. Humphrey Maris is splitting them. We know that they can be altered in their form to either act as a particle or to act as a quantum bundle of energy with a waveform. We know that they have complementarity. We know that hadrons in the nucleus can be broken down to quarks. We know the quarks can be broken down into subquarks. The standard model denies that there is such a thing as a subquark. Denies it. Even though 450 scientists at Fermi Labs signed a paper in 1999 that said, not only are they real, we reproduce them at will.
No one wants to recognize it.
And the guys who control the landscape on that stuff threatened Fermi Labs and that entire 450-man team with professional and economic extinction on condition that they retracted their paper.
Shit. Sounds like the Catholic Church.
Because Murray Gell-Mann,
is a religion.
Murray Gell-Mann, resident senior physicist at MIT, received the Nobel Prize in 1986 for his verification of 3 kinds of quarks. And the presumption was that the quark then became the smallest indivisible particle of matter, and, that was it. That's as far as it goes. And entire institutions, reputations, credentials, value are all defined now in terms of that being true. Science not interested now in finding out whether it is true or not, deeply invested in protecting the notion that it is. Then along comes a whole bunch of Gell-Mann students using the same device that he used 9 years later, and they split his quarks into subquarks. And that's not in the literature. But we have the report. We have the data. We got it off the internet before it was erased. It was not published. We know that quarks are made up of smaller stuff. And we know where that smaller stuff comes. And that's what this model is about. Is how does it come to be? What is it all about?
Solar information.
By the way, Gell-Mann was at Caltech.
Oh, was he Caltech? I'm sorry.
Same thing.
Well, that's why Ruggiero Santilli got into so much trouble. You know, he claimed that, I mean, he proved mathematically that quarks are not an indivisible particle of matter because they're not matter at all. Because they violate the Pauli exclusion principle.
So what are they if they don't matter?
I'm going to tell you that in just a second. It won't mean anything to you unless you know where we're headed.
Okay.
So, all right. So in the standard model, there are some fundamental things that don't work, and there are some pieces that are missing. And we're just going to fly across the top of this because we don't need or want to spend a whole bunch of time on it. What I want to get across here in this short session is to let you know that in the late 80s and early 90s, a guy named Ilya Prigogine and his partner Isabel Stengers got the Nobel Prize for publishing a paper called Dissipative Structures. And this was the time in which science pretended to prove that the entire universe is now headed to entropy. That having been created by the Big Bang, everything was now slowly dissipating. And they didn't stop to talk about the constellations that we now have high-definition Hubble photographic images of, in which new stars are as yet being born. And the question Isabel Stengers and Ilya Prigogine couldn't answer was, how is it that in the same universe, in the same regions of space, at the same time, we're seeing evidence of catastrophic annihilation literally in the same address as self-organizing criticality, organization with complexity, self-driven. How is it that if the universe is proceeding to entropy, that both those things are operating in the same place at the same time, and half of it is not entropy, half of it is self-organizing criticality? How does that work? And then along came one of my favorite people on the planet, a guy named Per Bach, worked at Brookhaven National Laboratories until they expelled him for heresy. He published a book called How Nature Works. And in his book, he used an example of the simplest of experiments. If you've ever been to the beach, you've all done this. He said, look, let's build a sand pile, and let's build a set of predictors that predict which grain of sand is going to precipitate a deconstructive avalanche in the sand pile. Let's see if we can predict when, where, and at what magnitude, with what frequency, these avalanche events are precipitated. Let's see if we can do that. So they took finely particulated sand, silica sand, dried, generalized the granules so that they now had only one variable. One variable was how many of them are there. That was the only variable. And they began stacking these grains of sand on top of each other. And they began counting. And they went through all kinds of rigorous protocols. And at some point or another, at some place or another, with some frequency or another, with some magnitude or another, eventually, at some spot on that cone of sand, it would slough away. They determined after several tens of thousands of these sample events that the sand pile at a point which is not knowable ceases to be a stack of individual granules and becomes an open, complex, self-organizing system that precipitates these critical events called avalanches, and that those avalanches respond to four basic rules. Four basic rules. Now these are really critical. In the science of this, we have an issue. And one of the issues is that the way science works by its methodology is it's like the 11 blind men and the elephant. And it really is, in a manner of speaking. And you got a bunch of very dedicated, hard-working, disciplined, really focused people with all kinds of tools and training and competence and rigor and discipline, and they take a piece of the elephant and they examine it and they examine it and they examine it, and they take what they know and they throw it on the wall, called published literature. Right? And then along comes guys like Brian O'Leary, and he sees all this stuff scattered on the wall, and he starts trying to figure out, how does all this crap fit together? You know, I mean, it's all part of the same science. How do these pieces fit? Then he makes some horrifying discoveries. One of them is that few branches of science use the same language, so they don't communicate with each other. Much of the information they produce is contradictory because they're asking different questions. It's hard to sort out who's asking the right question or whether the questions they're asking are the same or similar, because the language they're using, the mathematics they're using, the context of the questions is different, deeply siloed. So there isn't much relationship between the information in one brand of science and any other discrete brand of science. And all the soft sciences have now bought onto the idea that even psychology can be reduced to numbers. Okay. Even psychology can be reduced to numbers. If you've ever looked at a master's degree course in psychology, I mean, about 2/3 of the coursework is about predictors. It's all about statistics and probability and predictors, and catalog numbers of this and catalog numbers of that. I mean, it's insane. I mean, even psychological disorders are cataloged in terms of their numerical equivalents. It's called taking the unreasonable to insane lengths, right? So what you find out in the model of science is that science makes some assumptions. And here are the basic assumptions that science makes. One of them has to do with the speed of light. Science assumes that there are four underlying a priori local linear field effects that existed before the Big Bang. They have no idea how that happened, but these four field effects operated as mutually exclusive, distinct field effects that are theoretically mutually exclusive and therefore unrelated. That idea came around because the guys who developed these ideas didn't know each other. And they didn't talk to each other, and they operated in a vacuum with respect to each other. And by the time those things got formulated to a certain point, they became sacred. And the underlying assumptions were considered to be so indisputably true that they were no longer subject to question. I mean, that's the way that goes. So these assumptions are that before the Big Bang, there was gravitational field effects, there was electrodynamic field effects, there was a strong nuclear force that binds the nucleus together in the atom, and there's a weak nuclear force that binds the electrons to the nucleus. And that's it. As far as science is concerned, those four fields are sacrosanct, mutually exclusive, a priori, and there are no others. There are no others. Well, okay, sometimes we see this non-local effect, but that's just a special condition. So Einstein now has a whole new section of his general called the special theory of relativity, which deals with some of this other stuff that doesn't fit in that nice little package pigeonhole. Well, when you know things about nonlinear field effects, about non-local field effects, when you take Gazan's experiment with electron-positron pairs, when you take Alan Aspect's theoretical construct put into motion where the decision of the observer exerts an effect on that which is being observed and it's measurable and quantifiable, when you go to Drexel University and a series of subjects are able to bend a laser beam without touching it, just by focusing their concentrated attention on it, and literally able to bend a laser beam, when guys like Brian O'Leary come along and bend spoons by thinking about it, this relationship between the non-local, non-linear, holographic nature of mind and consciousness coupling with physicality suddenly becomes utterly unexplainable, because it doesn't fit. Non-local, non-linear field effects are not accommodated by the standard model of physics, except in extreme and arbitrarily imposed conditions, very special conditions. One of the evidences of that is that we have no mathematical expressions to express true non-locality. We can actually produce holograms that are truly non-local, but the formulas they use don't describe the non-locality, they describe the software that's used to produce them. Okay? So we begin asking this question. If the gravitational field effect existed prior to the Big Bang, and everything after that is a product, is an effect of this prior condition, how is it that we can mitigate gravitational field effects? How does that work? If there's an underlying governing principle, how does its product exert sufficient effect to mitigate the source? How does that work? Well, it doesn't work. Something's not right here. All right. So that's kind of the underpinnings. Well, don't do that. Okay.
Yeah, the other thing, of course, is that string theory is this kind of crazy attempt to reconcile those four known and presumed to be only forces of nature.
That is exactly right. In 1903, a guy named E.T. Whittaker published a seminal paper. We still have copies of it, even though it's been erased from the internet. You can't get it online anymore. It's pretty interesting. E.T. Whittaker was a Scottish mathematician who figured out, using partial differential equations, what the waveform structure, functions, and dynamics of gravitational field effects are. And he demonstrated in his papers that gravitational field effect is a product of finer scale interactions. It has a waveform, it can be mitigated by the imposition of external forces, it is predictable, and it operates according to certain rules. That paper created a firestorm in its day and was absolutely ignored because right behind it, within months, remember, this is not the time of the internet, it took sometimes 2-3 years for this stuff to get from one continent to the next. Right? Within months after Whittaker published his paper in Physics Review, Albert Einstein was awarded the Nobel Prize for Brownian movement. And general relativity became the order of the day, and E.T. Whittaker's information went right out the wall. It was absolutely ignored. It was absolutely correct, but it was ignored. It gives us the basis for considering what our model needs to look like. In the formulation of gravitational field effects, and we're going to move pretty fast here now, in the gravitation of gravitational field effects, there is, in some formulations, the use of a term that constitutes a self-feedback loop in the transverse wave function of a gravitational field. And the term is called Z. That is the same term that is used to generate fractals. Okay? And you'll notice in this description of Z, there's no equal sign. There are two arrows. Z leads to and gets feedback from itself squared at the speed of light, which connotes instantaneity. So, when you generate a fractal, you start with a seed, with a value, and that value then self-replicates with a feedback loop at the speed of light throughout whatever the continuum of the function is. If you substitute the Z that's found in fractal definition for the Z that's used in Plotnikov's gravitational field equation, you come up with a whole different animal. Gravitational field effect now becomes the engine that drives the physical embodiment of the fractal. Fractals are the geometric, physical, historical record of holographic interactions. Do you get that? I mean, this is not anything you will hear anyplace else. But there is a direct causal feedback loop that operates at every scale in the universe, from the finest to the largest, in which gravitational field effects play a role. And gravitational field effects only operate where mass is present. And at the first three scales of evolutional complexity, there is no mass. That's why at those scales, all the interactions operate in a timeless, distance-less, holographic environment. That dynamic converts what happens at these scales of increasing complexity into physical embodiments, like the geography of a coral reef, or the geography of a riverine delta, or the geography of the human brain, or the geography, the topology of mountain ranges or trees and the way they form forests. All of those physical embodiments are fractal. Every single one of them in their natural state are fractal. And they're all driven by interactions that occur in a holographic field that couple with physicality to create the record of the interaction. Fractals and holograms are the engine of creation. They're the engine. There is a set of numbers called the Fibonacci set. And the Fibonacci series of numbers works like this. It starts out with 0, plus itself is 0, plus the next integer is 1, 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. If you plot these numbers, some very interesting things happen. The Fibonacci series is the only series in all of mathematics in which the inverse has the same proportions as the direct product. It's really interesting stuff. And
Golden mean.
it is the golden mean. And it is fractal. It is purely fractal at every scale. And when you plot it, look what you get. You get the nautilus. You get that favorite curvature. Now, if you take that curvature and you plot it this way, you're looking down either into the middle of Hurricane Katrina or an F5 tornado, or one of Schauberger's water spouts, or the way the water drains down your toilet. Okay?
Galaxy?
Or galaxies, or super galaxies. It has everything to do with the way things are formed and distributed. So you can see them in space. You can see them here in the M51 galaxy and billions of others. So what we then find when we start looking at these pieces is if we take some fundamental assumptions away from the standard model and start from scratch and reevaluate it, what do we discover? We discover that there is at the core of all things, at below the finest scale, which is called the Planck constant. The Planck constant is either 10 to the minus 33 centimeters or 10 to the minus 33 seconds. That's a dot followed by 33 zeros. It's really, really small. So you begin asking yourself the question, is there anything finer? And lo and behold, there is. And we call it the physical vacuum. The physical vacuum has been scientifically validated, and the way we know that there is such a thing is that a guy in 1948, Cedric Casimir, did a mathematical formulation which was then physically, experimentally verified 4 years later. The Casimir principle says this. It says that if I have a plate of any material and it is perfectly polished at the surface, if I take a sphere of any other material and I begin to move that sphere in closer and closer proximity to the flat surface of the metal plate, there is a point in time at which, when the space becomes close enough, because of the dielectric constant differentials in the materials, electrons will exchange from one to the other. That can only happen when there's nothing else in between. Now we know today that, for example, if you take two pieces of marble and you polish them to 500 thousandths of an inch tolerance, and we can do that on demand, there are lots of people can do it now. You put those two pieces of marble together, you can't get them apart. You can't even slide them. Because the only thing that exists in that space between them at that fineness is the vacuum of the space that has the wavelengths of electrons and smaller particles. Everything else presses from the outside, from all directions. At above that tolerance, any less fine tolerance, you can move them apart. If you polish them to 1/1,000,000th of an inch tolerance, the outer shells of the electron shells of the atoms in the surface actually begin to overlap at 1/1,000,000th of an inch separation. If I cover those pieces with a thin film so that there is zero overlap, and I take that down to 1/1000,000th of a meter tolerance, the materials actually begin to migrate into each other. They actually begin to migrate, so that the atoms and the molecules in the crystalline lattice are no longer able to recognize which material they belong to. There is a physical vacuum, and this physical vacuum is a timeless, dimensionless field of undifferentiated potential. It's pure, unadulterated potential. Richard Feynman talked about it in his writings. He even calculated it. Our challenge then is to say, what do we know about stuff? If we start at the center, what do we know about stuff that tells us how nature works in a way that informs how we use it to do what we want to do? So what we've done then is two things in this model with this background. We've been able to identify the 10 scales of organizational complexity that operate in the universe and describe at which point in those scales certain phenomena begin to occur and how they come together. And the mathematics that describes how this is done and how it works was just published in Hawaii in October. They reformulated all of the general theory of relativity and came up with the equations that describe these interactions. We had no idea they were doing that, but they're now available to us, and we're going to go pay them a visit. So we have a patented model of the atom, we have a new model of interactions, and we now have physical validation that the principles work, and we now have the mathematical formulations say absolutely right. It took 5 years for all that to happen after it was published. So here's how it goes. From the physical vacuum, you then proceed to an event in potential, which we've referred to as a virtual ensemble. It creates one kind of potential that somehow comes into relationship with another kind of potential and hooks up, however briefly. In that realm, there's no such thing as time, because time is an arbitrary event denominator. It's a discriminator. It doesn't exist in that realm. There is no time. It's holographic. Virtual ensembles then come in contact with other virtual ensembles to create what science is now referring to as the qubit, the quantum bit. The guys at Fermi Labs referred to it as the subquark. And they identified two specific kinds of subquarks, each of which possessed variables on three different sets of properties. Those subquarks then come into combination and they form 6 different kinds of quarks with 6 different sets of behaviors and 6 additional sets of what they call colors. Virtually everything in the universe except the most exotic theoretical particles are comprised of just 3 different kinds of quarks in different combinations. Now, the determination about whether virtual ensembles come together to form qubits, or come together to form quarks, or come together to form hadrons, protons, neutrons, electrons, and fermions, and other kinds of, things that are all 26 of the nuclear particle index. Every time somebody tries to figure out something new, they invent a new one. One of which is called the graviton. It's another particle that somebody made up. The question you have to ask yourself is, as these things become more complex in their construction, what rules apply to govern this interaction? There are 5 that we know for sure. And they operate at every scale as far as we can tell. And here's what they are. One of them is called punctuated equilibrium. In the sandpile model, these avalanches do not occur.
Theory.
Yeah. Punctuated equilibrium. Everything's going along fine. You're building your sandpile, and it doesn't just kind of go away in one place a little bit at a time. All of it goes away right now. Punctuated equilibrium. Big changes occur very quickly.
Local.
There's no ramp up. But there's some issues with that, which makes it very interesting. So these changes in complexity occur either as increasing complexity or as catastrophic annihilation quickly, not gradually. What we also know is that for every avalanche of a certain magnitude, there are X number of other similar events of a smaller magnitude that is related to the original one logarithmically. There is a logarithmic power law relationship between avalanche events. We see that in nature. If you take the distribution of earthquakes along the fault zone, you take the distribution of tornadoes, hurricanes, volcanic eruptions, tsunamis, any naturally occurring event, when you map those, you find that not only is there a logarithmic distribution with regard to frequency or magnitude, but when you plot those, that becomes a single line with a single slope. It's not a curve. So when you do the plotting of these events, animal extinctions, mass extinction events, coronal mass ejections, they all follow exactly the same rule. And that's problematical because they organize themselves according to the fundamental principles of fractal geometry. The distribution is fractal. That is, that it operates in a way that is self-referential. And it operates in a way that discriminates, next rule, in quantum leaps, except with specific kinds of fractals that operate in the interstitial spaces between. and those are fractals of a different order, fractal geometry operates with quantum thresholds. That's why in electrons, for example, there's nothing between one orbital and the next. It's either this one or that one. They're quantum. When you try to move a boulder, you can work yourself to death and die and never move it if you don't exert enough force to break the threshold. It's called a quantum threshold. And in the physics, it's described as a noise threshold, 1 over F function. So you now have fractal geometries, punctuated equilibrium, power laws, quantum thresholds, and then you have the Fibonacci numbers. These distributions, the distance between, the spacing between electron orbitals, pure Fibonacci numbers. The configuration of fractals absolutely complies with Fibonacci numbers. The distribution of the planets in a solar system. In our solar system, the planetary orbitals are within 0.00043% of a perfect Fibonacci distribution all the way to Pluto. And it's true for every constellation we know about, and it's true for every galaxy that we know about, where these organizational functions take place. That's why there are archetypal forms. And here's how archetypal they are. You familiar with a thing called the Bose-Einstein condensate? You ever heard of that? Let's see if I have a picture of it here.
Sounds like a hell of a cocktail.
There it is. Now I want you to look at that picture. That's an image of a Bose-Einstein condensate. The guys who created that product deserved and got the Nobel Prize in Physics. What this is all the matter that remains in a hard vacuum, a virtually perfect vacuum, with only just a few molecules of anything, at 1/10 of 1 degree above absolute zero, 0.1 Kelvin. At 0.1 Kelvin, all of the relationships that we identify as archetypal are embodied in that shape. You have 3 quarks in each of 2 halves, and they rotate with respect to each other so that the net rotational value is 0. 3 quarks in each of those hemispheres are also operating, and their net sum is 0. This is the embodiment, the perfect embodiment of primal mass. At 0.2 Kelvin, that thing becomes 26 different kinds of mass in the same space. Just like that. Nothing in between. And that they didn't expect. That was a discovery. What this means is that that's a picture of how the universe works in a capsule. And everything does what this does. These relationships, the angles, are optimal angles. And they are the same exact angles as the slope angle on the Great Pyramid of Giza. 54.73 degrees. It's an optimal angle. We find it everywhere in nature. We find it in lensing. We find it in tornadoes. We find it in the structure, the dynamic structure of clouds and hurricanes and waves and earthquake predictors. We find them everywhere. So what this model really means in a nutshell is that this is a standing wave. This is a galaxy. That's the Bose-Einstein condensate as it begins to dissipate. And in the next frame, it becomes a vortex. It becomes the Fibonacci numbers taken out into its natural expression. Victor Schauberger intuited this. He saw this happening, and he got how that works right down to the nubbin. And that's why his implosion engine technologies served to unwind gravitational field effects in the locale. So you don't get gravitational field effects at all until you're 5 scales up. Because the first time you see mass, true mass, that is the product of underlying interactions, is in the 26 hadrons that make up the nuclear particles. Below that scale, there is no gravitational field effect. None. What that tells us is that mass is a product. And the key point of the whole thing is that if you read through Seeing Past the Edge, the very first statement in the very first paragraph says everything is information. Absolutely everything. How that information is organized is what creates the universe we live in. It's just information. So if we know that, and we know how all this hangs together, then when we're trying to figure out how to do a technological integration, we're trying to design a device that has a specific form and function and purpose. When we understand these dynamics, then we can build our apparatus to take advantage of what we know. And we don't get caught up in a lot of nonsense. What you know about this is that once these interactions begin at every scale, at the nucleus of the atom and above, where you have both local linear interactions for the first time, there's no linearity in the interaction until the nucleus of the atom. For the 4 scales before that, there's only non-locality and non-linearity. Nothing has time, and everything is holographic. Everywhere. From the inside out. And remember, this is not a static process. This is happening all the time. In every instant, everywhere, all the time. The virtual ensembles are arising from and disaggregating back into the physical vacuum. At the center of everything, they're doing that in a cycle. And the qubits, therefore, are connected to that cycle. And the quarks are connected to that cycle. And the neutrons and protons and electrons and atoms and molecules and matter and all of the aggregations are connected to that cycle from the inside out all the time. That's the local linear part of the progression. If these same rules are consistent for the interactions that occur in non-locality and non-linearity, in that holographic place that is timeless and without distance, where identity and mind operate, it is no wonder then that there is a constant that defines the place at which speciated functions in consciousness couple with physicality. That's no mystery anymore, because they both derive from exactly the same source in exactly the same way by precisely the same rules. They are organized together and inextricably connected at the core. At the core. That is why, when you figure out how to connect your consciousness in a way that couples with physical matter, you can alter the matter. In fact, if the Vedantas are correct, you cannot observe matter without exerting. You cannot observe it without exerting an effect on it. And we have the hard experimental evidence that proves that's true. In fact, John Archibald Wheeler, none other, formulated an experiment which he showed means he measured photons originating from galaxies 15 billion light years away. And he set up an apparatus to determine whether they came straight from the source or whether they were curvilinear and lensed by the field effects that are found in the universe. So he measured for nonlinearity, and he got that result. And just as a matter of interest, he changed the experiment and measured for linearity, and he got that result. And then he did the same thing that Alan Aspect did with electrons in a double-slit experiment. He set it up so that it would operate in both modes, and the only thing that changed was his choice from the same source. And when he decided to measure for linearity, it was linearity. When he decided to measure for circularity, that's the result he got. So something interesting is happening here. Either the human mind, in its function, is coupling with that source 15 billion years ago to alter the course of the photon in a way that is without time and distance. Because the same photon from the same source can't operate in both modes at the same time. At least not according to what we know. So it works at all scales. Works at all scales. So when we talk about doing technologies, when we talk about building devices, we talk about doing our science, that's one of the pieces of the equation. What we now know is that it's evident everywhere in nature, from qubits right on up to the, if I can get these images here for you, right on up through the largest, grandest scale of organization of all, which is the universe, which is truly infinite, which has no end, it has no center, it has no bounds, it didn't have a beginning and it'll never end. That's just the way it is. Get used to it. So we now have pictures of things that happen at these different scales. These are high-density charge clusters, pictures taken of toroids made entirely of electrons. Instead of dissipating away in a cloud, they organize themselves into a torus. Well, the finest particle of matter known to man at 1/10 Kelvin is a torus. It's the Bose-Einstein condensate. It's a torus. So we see this visited out. This is how the math works. A bunch of our buddies at University of Chicago produced the math that produces this interaction. So we know how they do it, and we know how many there are. So now we have pictures from IBM of an atom. We have pictures. I mean, thanks to IBM. Those guys are great. They do great stuff. We got great pictures. And we have atoms being organized to form patterns, deliberately placed in a pattern to do something very specific in a very specific way. IBM's doing that. And so are some other science guys. This is a buckyball. This is a buckyball. This is a 6th scale.
C60. C60.
Yep. Yeah, it's a buckyball. It's a picture of it with an electron microscope. And it's a piece of work. Now, this technology, the use of these nanotechnologies to make carbon nanotubes, is going to change the way the world works from the bottom up. It's going to change copper wires, it's going to change communications, it's going to change batteries, it's going to change energy delivery and storage, it's going to change everything. It's going to change medicine. It's already changing medicine. So that's where the universe is today, and all of this stuff, all of these vortices, smoke rings, that smoke ring is 200 meters in diameter. They got a whole bunch of pictures of them coming out of a volcano. You know, it's an archetypal form. And so, you know, here's a very interesting thing. This is just incidental, and I'll quit. There's a term called a follico-soliton. It's a standing wave in the form of a vortex. And what it demonstrates is that all vortices are connected by local linear and non-local nonlinear effects in the real world in a way you can do yourself. Here's how you do it. Go stand in the shallow end of a swimming pool. Wait till the surface of the water smooths back out. Take a frisbee or a pot lid with a handle. Put it down on the water and spin it and then remove it. After a few tries, you'll create a vortex. And that vortex will self-perpetuate, it will self-organize, it'll go right down into a little Victor Schauberger vortex down to the bottom, and then very shortly thereafter, in the surface of the pool, you will see its complementary half emerge. And if you want to see how they're connected, take one drop of ink and drop it in the water. And you can take a picture of it. The ink goes right down that filament and it comes right up the other side. You can do that all by yourself. That's how scalar communications is going to operate. We're going to build communications devices that do that holographically. That's how we're going to do it. And the data is the drop of ink. No wires. No radio frequency. Purely holographic. We built them, we know they work. So you look at Hurricane Katrina, you notice that the patterns are the same. You look at a water spout, patterns are the same. You look at all of these manifestations. You look at, soliton, standing wave. The Earth and the Moon is standing wave. By definition. Electrons, standing waves. Atoms are standing waves. And when you organize them together, then you get all of these extraordinary shapes. Neptune, Saturn, the distribution in our...
Could you explain a standing wave?
Standing wave is a stable toroidal organization of information. It is stable enough that it can be moved through time and space from one address to another. And as it becomes dynamic, it is a static form, except for the tensors and stressors that operate down inside there. But as it begins to become dynamic, to self-organize, it then becomes a vortex. So you look, we were talking the other night about where two rivers come together. You see a clear river and a muddy river. If you examine with real precision what goes on at the interface between those two flows of fluid, you'll see standing waves that become vortices. It's exactly the same phenomenon that creates tornadoes, that creates hurricanes. It's exactly the same. And it operates in much larger scales out in the universe.
I was watching dolphins swim at high speed.
Mm-hmm.
They do that with their tail once, and you get all these vortices all flying.
Right.
Any idea what that is?
Yeah, it's what's happening in the water with respect to the dynamic. It's a hydrodynamic effect.
Is that what drives it?
It is. They're riding the wave. They're riding the wave. They can ride the wave from the hull of a ship without ever touching the darn thing.
Yeah.
It's the same way a surfboard works. It's exactly the same phenomenon. Now, if you look at Hubble images, I love the Hubble. I'm so glad they saved it. Because some of the Hubble images are so fantastic. Here we have a galaxy of galaxies. And this galaxy of galaxies is called, it's referred to as the wheel within the wheel. And what you have is a galaxy with a very bright, large star circled by a ring of galaxies. These are not stars, these are galaxies of stars. So, this organizational thing, this is my favorite one of all time. This is called the Sombrero Galaxy. And what the Sombrero Galaxy demonstrates is, they look at it from edge on, and you can see the ring of galaxies around this nursery for stars. The center of this baby is the birthplace of stars. And when they're formed, that whole dynamic operates just like high-density charged clusters. It's exactly the same set of dynamics in a form that's 500 million light years in diameter. I mean, it's just so spectacular, it's breathtaking. And that's the universe we live in. But those are the rules. Wherever you have local linear effects, you must have non-local, non-linear effects. You must, at all scales. They are inextricably interrelated by the dynamic of creation. The world works in a dynamic system that is at every moment being created and uncreated in a cycle. Every instant, everywhere, being created and uncreated in an endless cycle.
Any idea what frequency that is?
It varies depending on the scale of organization, and it varies in terms of where you're looking at. But it operates. We think our calculations tell us that it operates at the opposite end of the Planck constant. That the wavelength is 10 to the minus 33 centimeters. Which means that it's operating at 10 to the 33 cycles per second, which is mighty damn fast. It's as close to infinity as you get. After 33 zeros, you don't care. So you see, now you look at science with a different pair of eyes. Light is not the upper limit to the velocity of data transport. Never was, but the construct is wrong. And gravity is not an underlying field effect, it's a product. Therefore, it can be mitigated. And the same is true with every other a priori field effect. And you can create a unified model that describes how locality and non-locality and linearity and non-linearity are related in a single set of field effects that are the result of self-organizing criticality. That's what this model tells you, that they are fundamentally related by form and function at every scale. And they're absolutely dynamic. So now, our job is to say, based on this information, when we talk about our technologies, what is our frame of reference with respect to evaluating and testing and designing our systems, our devices, our protocols? See, we know things now because of this information that's not generally available. For example, in the electrodynamic reformulation, one of the things we learn by reconstituting part of the quaternion is that Einstein was absolutely right about one thing. Before he died, he explained the importance of magnetic potential in scalar interactions. The magnetic potential is everything, he said. Physicists don't want to hear that because it undoes everything else they're trying to talk about. There is a point in the continuum at a fine enough scale where electrons travel at a finite upper limit. In the time it takes an electron to go 1 centimeter, a photon will go 11 meters. Okay? In the physical world, that's a big difference. So electrons have this finite velocity in a vacuum. Well, that velocity is always headed toward a magnetic potential. The charge always leads the ion. This magnetic potential always leads the physical element, the electron. The gap is at 5 nanometers, 5 nanoseconds. That's the gap. If we can do switching in electronic devices at 5 nanoseconds, we can perform work across the charge barrier without any amperage, 0. Tesla knew that. This says why. So if we have switching in our ultra-high-speed switching systems, if we've got superconductive, room temperature conductive materials, and we can conduct that charge barrier in a way that follows the potential at a fine enough scale, we never have to put an electron in there. We can perform work across the charge barrier with no electrons. It's all about the switching. So when we're design engineering motors and generators, instead of being at 60 cycles a second, we need to be at 6 nanoseconds duration. That's where we need to be. Because at that place, there's almost no electrons required to drive the work function. Because the magnetic potential always leads the charge, always. See, nobody in any physics class in America knows that. It's not taught. But we know it's true. And the closer you get to it, the amount of electrons that you need follows a parabolic curve. It's exponential. It's not linear. It doesn't go like that, it goes like that. So the closer you get, you really have an exponential advantage.
But can we switch that fast?
Of course.
Yeah.
We've got photonic laser switchers now that go to femtoseconds. So we can switch very fast. But the other issue, of course, is conductivity. Conductivity is associated with resistance. When we know what we know about this model, then we have some basis for creating a strategy that creates superconductivity, where there's zero resistance, there's zero capacitance, no electron buildup, no traffic jams, no need for stoplights. The magnetic potential leads to charge without resistance. Oh, baby. Now we have a conversation. Because if you've got that going on, you're now able to operate at the fourth scale. You're not at the fifth scale anymore. You're at the fourth scale. Because you've taken the delta T out of the charge barrier. There's no time. Superconductive means there's no time lapse between the exerting of the magnetic potential and the performing of the work function. Right? So, oh man. Well, what if we had a material that has no hysteresis? So when you drive the magnetic potential across the material, there is no loss to heat because there's no resistance. What if we could make all of our motors and generators out of a material that has zero hysteresis and superconductivity in its windings? How much amperage would we need to drive that? Zero. You can drive the voltage without amperage. That's what Tesla was doing. In 1905, he was doing that. Using all those primitive materials and technologies, he still did it and made it work. How he did it is right there. That's how he did it. Because he understood those principles. Well, we've got the technologies now. We've got the materials. We've got Vitroperm, electromagnetic material, that is demonstrated to have saturation ceiling of 18,000 Gauss. 18,000 Tesla. 18,000. In hell, our magnets are only 2.5 Tesla. We can't stand there and hold them. This is wonderful stuff. It never gets hot no matter how much amperage you drive through it at any voltage. It does not get hot. And we can buy it in any shape or form we want. We just order it.
And what is it?
It's called Vitroperm. It's manufactured in Germany at a place called Vakuumschmelz in Hanau. And our scientist Ed Price has been there.
Is it ceramic?
It is not ceramic. It's a metal foil. Nissan Heavy Industries manufactured it and didn't know what the hell they had, so they sold it for almost nothing. And the guys in Germany bought it and weren't sure what to do with it because they didn't know quite what it was supposed to be used for. And our guy Ed Price told them, "Do you realize what you have?" And they said, "No." He said, "Watch this." And he cranked it up with some real heavy windings and blasted monster amperage through it, and it did not get hot. Oh my God. They still don't get it, but they're catching on. And they tried to hire him away from everybody, and he said, "No, I don't want to live in Hanau, Germany." But we have access to the people, and we have access to the technology, and it is absolutely dead real. Absolutely dead real. So we're at the cusp in terms of the technology, the materials technology, and the science. We're at the cusp of being able to conceptually design systems and devices and applications and integrations that were absolutely never possible before. They were never possible theoretically. One, because the standard model prohibited it, and two, because nobody knew even how to think about that stuff. Well, we're not in that box anymore. We're not Kansas anymore, baby. It's a whole new ballgame. And it's on us now to figure out how to optimize the value of what we know so we can begin to drive these agendas. That's why the priorities we set in the next couple of days and the strategies we adopt are so extraordinarily important. Because we got a whole new toolkit that never existed before.
So, Dave, can I ask you this? I mean, I know that the science and the military and everything are doing all kinds of secret little things here and there and everywhere. But they don't understand this?
They do not.
Wow.
I know they're looking at it because I get some email from a guy at Boeing who's their chief design engineer. And I'm happy to correspond with him. I'm happy to correspond with him because the way he asks his questions really tells me a lot more than he thinks it does. So it's kind of a game.
And do you tell him about the weather?
No.
What an incredible amount of, I mean, this knowledge, whoever holds this knowledge has got such an incredible advantage over the current system.
It's hard to get it into the
Strategically.
game. I mean, we published this 5 years ago, Jerry. It's been on the internet for 5 years.
No one wants to look at it though.
Well,
It's complicated.
they do want to look at it. Today, if you Google Y-bias, you'll get 38,000 hits. That's how many websites are now referring to the Y-bias model out there on the internet. And all the time, we get these very interesting third-party validations from totally unexpected sources that tell us how right we are. And that's the fun of it. But the implications of it go well beyond just a theoretical model. So we're doing physical things with the information now that just simply couldn't be done before.
But look, that sort of knowledge and technology in the hands of someone who wants to do something good gives you an incredible strategic advantage
Of course it
over
does.
everybody else.
That's why I want to make sure you guys know this before we go any further.
Wow.
Because you now have access to the information. The next project we're going to do with this, we're going to write the book so everybody can understand what Y-bias means. So they can really get what it means and understand its implications.
I must admit, reading that part of it, I didn't read the whole book.
It's hard reading.
Kind of gave me a headache.
It's
Yeah.
hard reading.
Yeah.
Because the issue there is that we don't have mathematical formulas that talk about a lot of this, and we try to use words that are, not so semantically loaded that they become so indistinct that they don't have any real information. It's hard to use semantic language to talk about this stuff. I mean,
Where does the term Y-bias come from?
it is a fabrication that connotes the interaction of one aggregation of information in whatever form with another aggregation of information in some other form. One of them flows along an x-axis, one of them flows along a y-axis, and the angularity of their interaction is dispositive. What we discover is that when particles, photons, information packets intersect, interact, collide at a certain angle, the likelihood that they will breach that threshold and become self-organized into a higher state of complexity is much higher than if they intersect at a nominal angle. The angularity function of interaction is as important as any of the other components. And that's why, for example, in Japan, there's a guy named Minato who designed a permanent magnet DC motor that produces the same shaft torque as a conventional motor at 1/10 the consumption of amperage. And the way he did that was by taking his permanent magnets away from the typical perpendicular E field, B field intersection and angled it 54 degrees to 22 degrees. And that angularity optimizes the interaction between the fields and eliminates cogging in the motor. And now Toyota's using those motors in all of their heating, ventilating, and air conditioning systems in their automobiles. Because they only consume
Is it a
1/10
DC
as
motor
much
or
power.
is it-
It's a DC motor.
DC, yeah.
Yep. Yep. Yeah, he's a cello player.
Brushless or brushes?
It has brushes. They're working on a brushless option. But it's a fabulous technology. I mean, imagine being able to build an electric automobile that instead of needing 50 kilowatts of power to drive a 2,000-pound chassis at highway speeds, it only needs 5 kilowatts. Why, hell, if I can't produce 5 kilowatts out of sunshine and road heat, I should be out of the business. You know what I'm saying? And that design is a breakthrough. Look what it does to the way you design engineer a generator. If it does that with consumption, it must do the same thing with production. It must. It has to. It doesn't get to vote about it. But he hasn't done that yet, but he owns all the rights. As far as we know, nobody's been issued a patent that uses that technology to build a generator. Doesn't mean somebody hadn't applied for it. He probably has. But we understand the principle, and if we have access to things like superconductive materials and Victroperm core and other kinds of techniques and materials, no reason on the planet why we can't build, design, and manifest our own.
Incidentally, the superconductors I'm talking about are thermal superconductors, which it's not electrical, but
Well, we have some room temperature electrical superconductors. And the reason we know that why they work is because we understand what happens when you distort the field. Create a Meissner field by distorting the shape of the nucleus with an outside force. That distorts the shape of the orbitals. And it also causes the molecules, the atoms in the crystalline lattice to line up in a linear way so that the inductive field that operates across there is zero resistance. And to do that, now they've got a material that they've been working on at MIT. Those guys have all kinds of money and nothing to do. A bunch of guys took a special kind of material and they exerted 230,000 atmospheres of pressure in a compressor and mashed the surface of it, and it remains superconductive at room temperature.
so long as it's under pressure.
No, after. It permanently alters the electrodynamic configuration of the atoms in the surface of the material. Oh baby, oh baby. Here we go. Because now we know what, see, I can't afford to do that on my own, but I've got the paper. And the diagrams they used are right out of our slide presentation. I mean, it's amazing stuff. It really is. It's so archetypal. And now we're getting papers just in the last 30 days. People so excited because they're discovering symmetry at the finer scales. Well, why is that such a big surprise? Because the standard model says it doesn't happen. It does happen. It has to.
You may be able to explain how these thermal superconductors work.
Well, we'll sure take a look at it.
Yeah, I've got all the papers with me.
I'd love to have the conversation because that's also a very important element.
Well, they claim that they can get heat to up until the advent of this technology, the fastest conductor was silver. We understand.
Right.
They believe, or they've demonstrated, that they can convey heat at 30,000 times the speed of silver. And that translates to roughly 15 kilometers a second.
Well, what that means is that with a nominal heat source, say a thermal mass at 140 degrees Fahrenheit, if you've got a phase change gas like Freon, and you've got the ability to transfer heat from the thermal mass to the phase change gas at that rate with that efficiency, now you can perform work of all kinds of functions.
We're talking CO2 as a refrigerant.
Well, CO2 is a refrigerant, but there are 60 different fluids we know of that are phase change fluids.
Yeah.
And those fluids range from Freon to ammonia to, whatever.
Isopentane.
And so engineering and application, I mean, here's Ecuador, you got sunshine, and you got sunshine all the time.
That's the ambient heat engine, and you don't need sunshine.
Right.
You
So,
draw your energy right out of the earth or right out of the air.
so, then the engineering function becomes how do you optimize the value of that material to produce power, to perform work, to pump water, to filter it, to do whatever it is you need to do. And it gets local because it's scalable now.
And your byproduct is refrigerative capacity.
See, it changes everything. It changes everything.
Did you hear that?
Oh yeah.
The byproduct is refrigeration.
So give me an array of Peltier chips and I'll turn it into heat. Give me a thermodynamic, a thermoelectric chip, and I'll turn it into electricity. I mean, we've got all the underlying pieces, but what this does is drive the efficiency curve. So you have a major breakthrough in the materials, in the technology, for every rate of efficiency that you're operating with. At some point, Feynman's theoretical model that says there's 10 to the 80 joules of energy in every cubic centimeter of space. That's the potential that's driven by the physical vacuum to form the physical world and maintain it and sustain it. 10 to the 80th joules. That's 10 to the 47 joules more than all the power produced by the sun and its life expectancy in every cubic centimeter. Now, one thing I want to disabuse you of before I finish is this notion about 0 point. Okay? Between the physical vacuum and the time you tap an electron, there are 5 scales, 5 discrete scales of organizational complexity. You don't have to go anywhere near the physical vacuum to get power. Anywhere near. What you have to do is figure out how to get to the 5th scale and unwind the binding force or introduce some external effect that mitigates the binding force between the nucleus and the electron, and do it in a way that allows the magnetic potential to precede the charge. That's all you have to do. And you have access to all the power you ever want for anything you want to do. That's it. That's not 0 point. That's a 5th scale.
It sounds like almost like what you're describing here in many aspects, that there's a lot of terminology
There is.
that's needed.
Yeah, we don't have some language for it. There are still some formulas that we don't have ubiquitously available. But the concept is so fundamentally different from what's embodied in the standard model. If you take these concepts and apply them to string theory, you no longer need multidimensionality. Mm-hmm. Because non-locality and non-linearity are an essential primary function. So you don't need 11 dimensions and,
all that mathematics,
eight operators and 14 Lagrangians and all that stuff. You don't need it.
Yeah, it's the denial of consciousness.
Yeah, exactly.
Non-locality is a force. Yeah.
But consciousness is a product. I mean, speciation is exactly the same non-local, non-linear holographic function as the speciation of an atom. The difference is that there isn't a difference, because where you have a species of identity, you also have individuation. That's fundamentally consistent here. It's fractal. It's fundamentally consistent. That's why when Sheldrake talks about how is it that birds of a species know, how is it that butterflies know, I mean, butterfly consciousness and bird species consciousness are speciated, but each of the individuals are individuated. They are fundamentally unique and distinct in some finite, measurable way. It's true with all species. The idea that the species that are on this planet are the only species that are possible is unadulterated bullshit.
Yeah.
It's just delusional, because it's not consistent with the rules. Of course there are other species. There have to be. There's an infinite fractal array. That's just the way it works. So think about the implications of that.
So there's no question, there's no possible question that there is not some form of replication, of approximation of
Look, these rules operate everywhere in the universe with absolute consistency. They're not different in Orion because it's out there. It is out there the way it is because it's the same as what is here. And as soon as the astrophysicists figure that out, there's going to be a real revolution.
Yeah.
But they own all their special conditions. They own all their special rules.
We kind of hit around at it, or we did, the anthropic principle, for example.
Well, there are people think, and they're very smart people.
Yeah.
And that's why there are so many dissident scientists now, bailing out.
Right.
I mean, they literally are bailing out of conventional physics and science and gravitating to these conversations like this all over the planet, online, with groups like the Natural Philosophy Alliance and, the International Tesla Society. I mean, there's hundreds of them out there now. And it's impossible to keep up with them because they keep popping up. Much of it comes from Australia. I mean, there's just a wonderful wellspring of this extraordinary, innovative manifestation that comes out of Australia. It's popping up everywhere. We see it all the time. And it's impossible to keep up with it. So that's why bias. That's why bias. That's the model. Don't expect you to remember any of that stuff, except just remember that it operates from the inside out, not from the outside in.
I'm so pleased you didn't have any mathematical formulas.
I got a bunch of mathematical
I'm pleased you
formulas.
didn't talk about it because they confused me more.
Well, I didn't talk about them because I don't want to confuse you. They don't mean anything, it just piss you off. So,
Do you have any analogies that you can use to explain some of those phenomena?
oh sure, talk about
Because
specifics.
I think that like that river and ice analogy is a really good one, and it seems to get that, you get what you're saying.
Well, that's in Seeing Past the Edge. It's in there.
Yeah.
It's in there. And I didn't think that up. I mean, I stole that from somebody else. That's a great metaphor.
Yeah,
I have no hesitation in using the best stuff I can find wherever I find it. So,
Yeah, it's all on the public. Yeah,
it is, for sure. And we give attribution every time, so.
Ownership is an illusion anyway.
Well,
Yeah.
it's not one of my issues. I don't own it. See, this is the product of about 25 years of really concentrated work on my part, but I'm standing on the shoulders of at least 1,500 other people whose work I quoted, and probably 15,000 other people whose work I didn't quote.
Yeah.
I mean, I didn't invent a lot of that stuff, but we looked at it different, that's all.
It would be a manifestation of the collective consciousness, in a sense, wouldn't it?
Yeah.
I mean,
Well, in a way it certainly is.
yeah.
In a way it certainly is. See, the proof of that is that we now have independent validation of the fundamental precepts coming out of places like the United States Patent Office and reformulation of the general rules of the theory of relativity. Those formulas now are pure Y-bias, and angularity shows up in them, and they don't understand why. It's very interesting. So, there you have it. Took longer than 20 minutes, but I wanted to make
Thank
sure you understand.
Yes.
Okay.
And